For centuries, the stars were a man's world. They studied them, named them, and wrote the laws that seemed to govern them. The narrative of the cosmos was written almost exclusively by men. But slowly and quietly, a group of remarkable women began to rewrite that story. They weren't just looking at the stars, they were listening, calculating, and seeing things no one had ever imagined. This is the story of how 3 women changed everything, and why the universe would never look the same again. Our journey begins in the late 19th century at Harvard College Observatory. Here, a young woman named Annie Jump Cannon spent her nights gazing at the heavens. Annie was almost completely deaf, a condition that developed in her early adulthood. But this loss of hearing didn't disconnect her from the world. Instead, it seemed to sharpen her other senses, allowing her to listen to the stars in her own unique way. She joined a group of women who would become famously known as the Harvard Computers. Their job was to process the vast amounts of astronomical data that the male astronomers collected through the telescopes. It was meticulous, often tedious work, and they were paid far less than their male counterparts and rarely received credit for their contributions. For many, it was just a job, a series of calculations and classifications. But for Annie, it was a calling. While others saw routine, Annie saw patterns, a secret language hidden within the faint light of distant stars. She had an extraordinary ability to classify stars based on their spectra, the unique fingerprint of light that each one emits. She could classify up to 3 stars a minute, a speed that was simply astonishing. Over her incredible career, she manually catalogued more than 300,000 stars, a record that remains unbroken to this day. But her legacy isn't just about the sheer volume of her work. Annie Jump Cannon created the stellar classification system that astronomers still use worldwide, OBAFGKM. You might remember it from the mnemonic, "Oh, be a fine girl, guy, kiss me." She took a universe of chaotic data and gave it order, providing humanity with a new grammar to read the language of the cosmos. She turned the starlight into a story we could all understand. But the story of rewriting the cosmos didn't end with classification. A few decades later, another brilliant young woman would look at those same stars, organized by Annie's system, and ask a question that would shake the foundations of astronomy. Her name was Cecilia Payne. In the early 20th century, the prevailing scientific consensus was that stars were made of the same elements as Earth, just much, much hotter. It seemed logical, intuitive, and it was the accepted truth. But Cecilia wasn't one to accept things just because they were conventional wisdom. She was driven by data, by the evidence she saw in the stellar spectra. In 1925, for her doctoral thesis at Radcliffe College, which was essentially the women-as college for Harvard, Cecilia Payne published a conclusion that defied everything scientists believed at the time. Her meticulous research, analyzing the spectral lines of countless stars, led her to an unthinkable conclusion. Stars were not like Earth at all. They were composed overwhelmingly of hydrogen and helium, the 2 lightest and simplest elements in the universe. This was a discovery of monumental importance, one that would fundamentally change our understanding of stellar evolution and the composition of the universe itself. But how was her groundbreaking work received? It was dismissed. It was ridiculed. The esteemed astronomer Henry Norris Russell, her own advisor, told her she was wrong and persuaded her to remove the conclusion from her thesis. He called her findings clearly impossible. Heartbroken but respectful of her superiors, Cecilia downplayed her own discovery in her final publication. She wrote that the surprisingly high abundance of hydrogen and helium was almost certainly not real. It was a compromise born of the intense pressure and skepticism she faced as a woman in a field dominated by men. The irony? Just 4 years later, Henry Norris Russell, using different methods, arrived at the exact same conclusion. He published his findings and is often credited with the discovery. It took decades, long after her death, for Cecilia Payne-Gaposchkin to be fully and widely recognized as one of the most brilliant and important astrophysicists of the 20th century. She discovered what the universe is made of, even when the world wasn't ready to listen. And then, as the 20th century marched on, came Vera Rubin, the woman who saw what no one else could see. She was a force of nature from a young age, fascinated by the stars she watched from her bedroom window. She fought tooth and nail for her education and her place in the scientific community, facing overt discrimination at every turn. She was the only astronomy graduate from Vassar College in her year. She applied to Princeton's prestigious astronomy program, but was barred because they did not accept women, a policy that didn't change until 1975. Undeterred, she pressed on, earning her Ph.D. from Georgetown University. In the 1960s and 70s, Vera began studying the rotation of galaxies, a subject that many considered a settled field. But Vera had a feeling something wasn't quite right. What she found was utterly perplexing. According to Newton's laws of gravity, the stars on the outer edges of a spiral galaxy should be moving much more slowly than the stars closer to the center, just like the outer planets of our solar system orbit the sun more slowly than the inner ones. But that's not what Vera Rubin's observations showed. She discovered that the stars on the edges of galaxies were moving just as fast, if not faster, than the stars near the center. The galaxies were spinning too fast to hold themselves together. The visible matter, the stars, gas, and dust, didn't have enough gravitational pull. This could only mean one thing. There had to be something else out there, something massive, invisible, and holding everything together. Her groundbreaking observations provided the first solid, compelling evidence for the existence of what we now call dark matter, the mysterious, unseen substance that makes up about 27% of the universe. For perspective, the normal matter that makes up everything we can see, planets, stars, galaxies, you and me, accounts for only 5%. Vera Rubin had uncovered the vast, hidden scaffolding of our cosmos, but like Annie and Cecilia before her, Vera faced immense skepticism and resistance. Her findings were initially dismissed by many of her male colleagues. She had to fight for telescope time, for respect, and for her ideas to be taken seriously. She once famously said, there is no problem in science that can be solved by a man that cannot be solved by a woman. And she proved it, not with arguments, but with undeniable discovery. She revealed a universe far stranger and more mysterious than we had ever dared to imagine. 3 women, 3 different eras, 3 revolutions that fundamentally reshaped our understanding of the universe. Annie Jumpcannon took the chaos of the night sky and gave it order. Cecilia Payne looked at that order and revealed what the stars are truly made of. And Vera Rubin looked at the grand structures they formed and showed us the invisible force that holds them all together. They were trailblazers, geniuses who worked in the shadows of a system that often sought to ignore, dismiss, and forget them. But their light, much like the light from the distant stars they studied, could not be extinguished. It traveled through time, through prejudice, through obscurity, to reach us today. Today, their work is the bedrock of modern astrophysics. Every time an astronomer uses the OBAF-GKM classification, they are using Annie's language. Every time a scientist models the life cycle of a star, they are building on Cecilia's discovery. And every time we talk about the great mysteries of the cosmos, like dark matter and dark energy, we are walking a path that Vera Rubin first illuminated. Their stories are a powerful reminder that genius knows no gender, and that curiosity is a force that can and will overcome any barrier. They dared to look up and ask the biggest questions, even when the world told them to look down. If you believe these essential stories deserve to be remembered and celebrated, please give this video a like and share it with someone who loves science and history. And don't forget to subscribe for more stories of the unsung heroes who have shaped our world. Thank you for watching.